Okay, let's go ahead and get started. Welcome to the course on prescriptive optimization. My name is Joe Miller. I'm the Senior Learning Strategy Manager here at Alteryx. What we're touching on today is one of my favorite topics, and for a couple of reasons. The first of which is taking something that's previously thought to be out of reach for a lot of people and making it in reach is something that's really exciting, and this is something that an optimization tool provides. And I think the second one is realizing how easy it is to apply a tool like this in your life and how often you'll really actually use it once you know it. Even me, from my own perspective, I use it in my day-to-day, even outside of work. Something as simple as fantasy football, for example. I use the optimization tool to optimize the number of players that I can put on my team, or the type of players that I put on my team, while staying within a budget, and who of those are predicted to score the highest. So this is a really exciting topic for me, and I have a lot of fun with this. One of the things that I will say before we even touch anything in this content is we're really training on one tool today. So you would kind of expect right off the bat that we'd be out of here in 10 minutes. It's quite the opposite. Well, this is only a one-tool solution. There's a lot more background thought, and you have to be a little bit more cerebral in your approach to make sure this works. So what we're going to walk through today is really the understanding of what we're doing, how to approach a problem, and how to apply it to the optimization tool. And believe me, you'll thank me that we did if this is your first time, because it can be hard to approach if you don't have a plan of attack. Before we get started any further, though, I just want to make sure people know that the session should last us up to the hour. Everyone is muted by default, so if you do want to reach out to me during the duration of this training, you can go ahead and go to that Q&A window there at the top of your window or on the side, depending on your view, and just enter something in there if you have a question for me. I'll try to answer that as I'm going along. If it's something that's a little further off or I'm going to visit, I'll get to at that point. So just letting you know that, well, you cannot speak out loud. I can see what you are saying. So, and the other thing that I'm going to differentiate between is that there are two types of windows to communicate with me. There's a Q&A, and then there's also a chat. The benefit to me by using the Q&A is that I can actually mark people off as I've answered their questions, so it's easy to see if there's a new question in or not. So if you do have questions, I ask that everybody throw them into the Q&A, and I'll try to address them as they come up. So, and that is it. And then finally, this session is being recorded. So if we do go through something very fast or too quickly, you can come back a week later from now and replay everything that we did here. The final thing that I will make note is, for many of you, you may have come through this post right here, Prescriptive Optimization, to be a part of this training here today. You will see that I have included everything that I'm about to build as a download. So you can go ahead there and click that and follow along, or just watch. Because I think this is going to require a little bit more thought than you might be used to with Alteryx tools, which is kind of funny because I was just thinking about this earlier this morning, how I use tools to kind of build my thought, right? I'll build 5 tools and realize what I'm doing and maybe erase 3 and put in 1 more, and I kind of shape what is really happening with my data. Whereas this one, you really have to, I sometimes sit down with a piece of paper and draw out what I'm about to do. So this is going to be a little bit of a different style of working with it, so just be patient as we go through this presentation, because when it comes to the actual execution of the problem, it becomes much quicker if you have a plan of attack. But what I am going to cover is, coming up here, we do have some more live trainings that were just posted last week, so feel free to check those out. You'll see that I have them listed here. So in December, we have in database training, one on fuzzy matching a week later, and then one more to round out the year on dynamic workflows. So anytime that you might have a workflow that keeps breaking, or as your data changes, it breaks, this might be the workflow or the training for you, because we're going to talk about how to be a little bit more dynamic for your data, so you don't have to go back and always repair those workflows every time a new field comes in or a certain value changes. So those are some of the upcoming trainings. Those are available to you. We're going to go through some workflow background, which is going to be extensive today, just because I told you that you had to be in the place of mind to really think about that problem. And then the designer will be a little bit lighter, just because once you have that plan of attack, it becomes much more easy to execute on. And then finally, we'll cover off on some support items. If you haven't explored the community beyond the Academy piece, please do. you'll find that there's a wealth of content, not only just on that prescriptive optimization tool that we're going to be working with today, but really about anything. In fact, you'll see that most questions are answered within the day. So if you have any times where you get stuck, go ahead and plug it into the community and see if it gets answered. There's excellent blogs. You can submit your ideas. Really a great platform for a lot of people to interact on, and really one of the great pieces that makes Alteryx great. Alteryx Academy, I always make this a quick shout out, but likely if you're here today, you know all of our offerings. What you're in today, this live training, is just one piece of a multiple pieces. So one of them is interactive lessons. So this is something that's really for people that are really getting introduced to the tool. So if you maybe are more experienced, as you might be as you come here today, I would recommend this for other people. The other thing that I do is weekly challenges. So there are some weekly challenges out there right now, today, that test your knowledge on the optimization tool. So one of them is, I think it's called like Formulate the Best Community Team Challenge. So that would be one to check out if you actually want to try your own work through problem. So let me just jump over here and see if I can search for that very quickly. I think it's like an all-star team here. Well, I'll have to look it up. Here it is, Making a Weekly Challenge Dream Team. So that's going to be challenge number 111 is going to be using that optimization tool. So if you want to try that out, go there. And I also put this training on purposely because we're going to be rolling out our Santalytics lessons, or sorry, not lessons, our Santalytics challenges in the upcoming weeks, where, hint, hint, optimization will play a role if you want to participate in that. And then finally, if you want to jump into product certification and prove what you know, go ahead and do so. And I will tease that the most expert level exam did see an optimization tool. So this is something that we think is really important for people to understand when they go to work with Alteryx. So let's jump into actually working with this problem. So I'm going to read this off, and I know it's going to be a little bit long, but I really want people to break this down word for word, because we're going to extract little bits of information that's going on here to formulate our answer. And when I talk to people about this, I say kind of approach any optimization problem no different than any other standardized test problem, right? You know there's an answer, you just got to draw it up the right way or build it out the right way. So you're going to see some techniques in here. If you've maybe taken a standardized exam in the last 10 or 15 years, they might seem pretty familiar if you're working with that. If not, no worries. It's nothing groundbreaking, just something that you might have to think through. So here's our use case. There's a clothing manufacturer that has 750 square feet of cotton textile and 1,000 square feet of polyester. Okay, so they're building, or they're manufacturing clothes with 2 sets of material, and we could assume this is maybe a daily basis. Every pair of pants needs 1 square foot of cotton and 2 square feet of polyester. Every jacket needs 1.5 square feet of cotton and 1 square foot of polyester. However, due to the manufacturing restrictions, no more than 400 jackets can be produced in a day, but at least 200 pairs of pants must be manufactured. The price of pants is fixed at $50 and jackets $40, and that is MSRP as they sell in the stores. So what is the number of pants and jackets that the manufacturer must give to stores to obtain a maximum sale? And of course, there's some assumptions going in here. We're selling them, we're assuming that all of them sell, right, from the manufacturer here, or we could say that they sell to the manufacturer at $50 or $40 a piece wholesale. So there's a few things in there, right, and that's a lot of information that we threw at once, but hopefully we clear it up. And I'm going to break this down slide by slide, step by step, to know where we're going to go. And what I will note is that in optimization problems, there are different types of problems, okay? So many of them that you're going to come across are linear. So linear would be something saying like this, where the more jackets and pants I sell, the more money I get. That's a fairly linear relationship, so this is a linear problem. There are other types of problems that I'm going to touch on, but we're not going to address today, because more often than not, you'll see the linear problems in use. So let's go into that and dig into this a little bit more. Now, before I break down this problem piece by piece, let's talk about this prescriptive palette that we're in. And when I say prescriptive, I'm talking about the area of designer that we're in, right here. Okay, this is where our optimization tool lives, and you can see that there's 4 tools here. There's a lot of different types of analytics out there. There's descriptive, which is your normal analyzing summations, averages, means, medians, modes. Nothing too crazy, but it's really, straightforward, something that a lot of line of business analysts can do. We've got the world of predictive, which says what is going to happen, and then this prescriptive is what you should do, right? It's actually prescribing what you should do based off what's been predicted or what information you're giving it. So this is really something that's taking predictive to the next level when you think about it. It's actually putting things into action. So that's what's going to be really exciting about this. So we're going to cover that linear programming, and more specifically, we're going to build a manual model manually, just because we want to really refine our knowledge of the problem itself rather than the configuration of the tool. And then we'll show you an example if you were to build it from matrices, how you would do that. So let's go ahead and break down this problem and make sure that we understand what's going on here. The first thing that you need to do when approaching a problem is identify your variables. So everything in here is pretty fixed, right? There's a certain number of square feet allotted per day, the ratio of polyester to cotton for each article of clothing remains the same. There is some variability in how many jackets and pants are produced, though, right? How many pairs of them? The price is also fixed at $40 or $50. So the real variable piece within this is pants and jackets, more specifically, number of pants and jackets. So I'm going to identify those 2 pieces as my objective, okay? The objective being, what are the number of pants? And usually within these problems, it's actually explicitly stated, so keep a close eye on that. But what is the number of pants and jackets the manufacturer must give to stores for these items to obtain a maximum sale, okay? I could assign these any variable letter. I could have done P for pants and J for jackets, and that is a lot easier when we go to configure model manually. But what I'm going to show you is how to solve this problem algebraically via slides. And X and Y play a little nicer because we're familiar with X and Y axes. Or axes, I should say. So that's the only reason why I've labeled them this way, is just to make it a little bit easier, a little bit more approachable for this training to understand what's really going on. So I'm going to say pants are X and jackets are Y, the number of them that I sell, that is. So we've identified our variables. Now what we really need to do with those variables is really say what our objective is. Well, again, I identified my objective here on the bottom, right? And that's to maximize my number of sales. How would I calculate the number of sales? Well, what I would do is calculate what the sales for pants and jackets would be, which are unknown at this point based on the number of pants and jackets that I have. But I'll say $50 times however many pants I sell plus $40 times however many jackets I sell is really going to be my sale, right? And right now, we're not looking for maximum or minimum. You're just going to say what's going to calculate that sale. And inside this tool, we can choose whether we want to maximize that or minimize that. But essentially here in this objective function, I'm saying what's going to achieve that sales via equation. So 50 times X plus 40 times Y is really going to come out with how much money I'm going to make in this scenario. So what I'm going to do to make it easier to understand what we've addressed and what we haven't now is I'm just going to strike through those words to make sure that everybody sees what we've covered and what we haven't. Now, there are 2 types of things that we need to identify last. One of them are constraints and the other is limits, okay? And limits are really what they sound like, right? It's just this natural hardline item saying it's just no more than 400, less than 200, right? They're just limits, or I need a minimum of 200. These are limits, and we're just going to ignore those for now. But I have to identify what my constraints are. So what is going to stop me from selling $1 bajillion in pants and jackets, right? There's got to be something that limits me from doing that much. Maybe it's time in the day. Maybe it's how fast my manufacturing line can go. In this case, and in this problem, my limit is the amount of material that I have. So we have 750 square feet of cotton and 1,000 square feet of polyester. And that's going to be my real limiter. But beyond that, it's just not how much of those I have, but it's how much each of these use, right? So the more times that I use a pair of pants, that's taking away the amount of polyester that I can use for a jacket, so on and so forth. So you can see how this problem becomes more complex if you're trying to hand solve this or trying to work it out. Now, imagine that we had 100 articles of clothing with 100 different ratios, right? It almost becomes impossible because then we're working on more than just one axis at a time, right? So we're really only working with two things. So this may seem difficult, but as soon as you start adding third and fourth variables, it becomes well more difficult. So what's going to keep us is this whole section here, the number of square feet of textile or cotton and polyester. Okay, and what I've done here is I've broken this down into a really nice grid and saying, hey, for each pair of pants, which is X, I can use 1 square foot of cotton and 2 square feet of polyester. Jackets use 1.5 square feet and 1 square feet respectively. Now across the way though, right, I have another calculation that pants use 1 square foot, jackets use 1.5, and this is out of my 750 available square feet, and the same thing goes for polyester. This may be one of your most difficult parts of your problem, is creating the correct constraint function. And the reason that I named them X and Y is that you can actually build them into a nice formula, right? So in this case, I'm going to say, I'm going to build a constraint saying 1 square foot of cotton, 1x, which is just reduced to x in a formulaic view, plus 1.5 square feet. Whatever the number of pants I sell with 1 square foot of cotton, whatever number of pants I sell with 1.5 square feet of cotton, the summation of those cannot exceed 750 square feet. It can certainly be less, but it can't be more. The same thing would go for polyester. So 2 square feet times whatever number of pants I manufacture, plus 1 square foot of whatever number of jackets I manufacture, cannot exceed 1,000 square feet. So that seems pretty straightforward. I've built my variables saying what those real constraints are for those variables. Okay. Now we get to the fun part. Okay. We get to actually say how we're going to represent this. And then what I'm showing you is the engine underneath, what's really happening. So you can really understand what's going on, and you don't have to just trust the tool. You can understand what the tool's doing along the way. So what I'm going to do here is just show this very simple, straightforward graph here. Let me see if I can get my presenter view up here to better annotate this. So what I have here is my y-axis and my x-axis. And you remember x was equal to pants, so I'll just say P for now. And y was equal to jackets. Why is this important? Because these numbers, 0 through 1,000, represent the number of jackets I'm about to sell, and x, number of pants, equals the number of pants that I'm about to sell. So what I'm going to do is I'm going to come on here and model my constraints to show what is and is not possible. So let's start with the cotton constraint. And what many of you may or may not remember how to calculate the slope of a line. The slope of a line was y equals mx plus b. Okay, y, m being the slope, b being the intercept. Okay, so what we're going to do to make this easier is I want to isolate y onto the left side of my equation to really determine how to draw this slope out. So I'm just going to walk through the algebra here, saying that we're going to subtract x off of the left side onto the right. So it's negative x plus 750, still leaving the 1.5 y. And now I'm just going to divide everything by 2/3 to get the final equation, which is y is less than or equal to negative 2/3 x plus 500. So I'm going to go ahead and draw out that line and what that looks like. And I will say it's less than or equal to, which means that it's going to be on the bottom side of this line. So welcome to this new scenario where I've modeled out my cotton constraint. What I call the shaded area is really the area of feasibility. Okay. With this constraint, this realistically shows me what my manufacturing scenario looks like. So using my y equals jackets, x equals pants, right? I could sell 0 pants and 500 jackets, or conversely, I could sell 0 jackets and maybe 750 pants, or I could do something in between. Any single coordinate inside the space represents something that I can feasibly do within my constraints. I just want to know what the best version of that is. Which one of these points are going to give me the best profit? We don't know that yet. And we also need to add in our polyester constraint. Okay, so what I'm going to do is I'm going to do the same thing. We're going to isolate that y, and we're going to see the slope is -2 with the intercept being 1,000. So I'm going to redraw that line and say, hey, it's also less than or equal to, so we're going to put that underneath the line. And you can see yet again, my actual area of feasibility has been reduced, right? So while this area worked for the cotton constraint, we also see it doesn't work for the polyester. So we have to update it. So now, really, if I sold 0 jackets, the most I could sell was maybe 500 pants, right? So you can see our space shrinking down slowly and slower and slower, but we're not done yet, right? We need to identify the bounds and limits of our manufacturing. So we said, due to manufacturing restrictions, no more than 400 jackets can be produced in a day. That's a max of 400 jackets. And a minimum of 200 pairs of pants are required. So I'm going to build that out, and these are even easier because you don't have to really construct a complex formula. I can say jackets, right, has to be greater than or equal to 0 and less than or equal to 400. Now, it never said 0 inside of here. What I'm doing is saying there's really no negative manufacturing. There's an inherent 0. We're not, I guess, deconstructing jackets. There could be some rule in your company based on quality assurance if a failed manufacturer is a -1. But we'll say in this case, it's a perfect scenario. Everything is 100% mark. Jackets are all going to be produced, so it has to be at least 0, right? We have to manufacture at least 0. It cannot be -1. And it has to be less than 400. And then pants, we don't have to worry about the inherent 0 because it's already higher than that. We're going to say 200. However, we were never given any max, so we could say up to infinity, right, pairs of pants. We know based on what we just saw that might not be reasonable because we already saw the area of feasibility doesn't stretch that far. At this point, it stretches only to roughly 500. So let's go ahead and take those bounds and build them into our graph. So first I'm going to plot out that y is greater than or equal to 0. And you see that little pink line drew right here. So it's there. It just really didn't affect the area of feasibility, right? But we just wanted to make sure, just in case it doesn't stretch down here, because it technically could have gone all the way down here. So we're going to take care of that. And then we'll also say y is less than or equal to 400. So I kind of trim a little bit off the top saying I can't go up to 500 pairs of jackets in this case. And then we're going to go ahead and build in x is greater than or equal to 200. And now I have my final area of feasibility. So if we're looking at this, right, we could probably identify visually what might be the optimal combination of pants and jackets to sell in order to achieve the maximum sales, right? It's probably not down here. It's probably not this corner. It's probably one of these 3 points. Now, algebraically, you may or may not care, but I'll do it just to show you how we get there, okay? So what I would have to do in order to solve this is calculate what the coordinates are where each of these lines intersect, okay? And right now, I'm going to spoil the answer, and I'm going to say, by the way, it's going to be this one. This is going to be your maximized sales. So I'm just going to show you how to find that. So what I'm going to do is, for these 2 lines, these were my 2 constraints, right? Where y was equal to -2x plus 1,000, y was equal to -2/3 plus 500. Since they were both equal to y, I can just set them equal to each other. And what I'll do is just solve for x, right? So I'll reduce that, and finally I find that my x is equal to 375. So that represents where this is at that point. X is equal to 375. And now I can go in and plug in that x value into one of my slope equations. So you can see the easiest ones was this -2x plus 1,000. Solve for that and find that y was equal to 250. So there it is. My coordinate 375 and 250, right? So what this is saying is my x is 375. I can sell 375 pants and 250 jackets, and that will be my maximum sales. Now, if we were to plug this number back into our objective, right, x and y, we could actually figure out how much that ends up selling us, right, or selling for us. So I'll go ahead and plug those in, 50 times 375, 40 times 250, and my final result would be $28,000, $750. Whew. All right. that was a lot, but I hope that by visually explaining it, you felt a little bit closer to understanding how we get to that answer and really trusting the output of that tool. Now, let's talk about manually configuring this tool, okay? And I think this will be better actually in the tool itself, so I'm going to jump out of this and just bring up the designer itself, and we'll go ahead and get started. So you can feel free to open your designer if you do see fit. If you just want to watch, that's great, and do know it is being recorded. So I'm going to go ahead and bring in this tool, and I'm just going to zoom up here because this is a one-tool workflow, which is really great because it's such a complex problem. And we're going to go ahead and get started, right? So there's a few selections here, and it's just easy to work top-down, okay? So the first of which is really how we want to input our data. And in this case, I could specify a model as matrices, aka what this means is, hey, I'm going to have incoming data that I want to use to calculate my optimization problem. And that's really the only one that uses it. Enter a model manually, which requires none of the inputs, and specify a model from a file, which also doesn't require anything as well. If you already have a file that's already built for these optimizations, you can just plug it in and run. But for many people, I like to show this model manually because it really walks you through the steps of what we just did. And then once you get more comfortable, you actually start running as matrices. And that matrices view becomes more powerful because if you can imagine in our manufacturing scenario, the amount of available textile will vary day to day, right? Maybe I want to run this daily to see what my projected output should be or what my number of pants and jackets should be that day. Or maybe I have something that varies daily on the ratio that I put into those pants, or how much each of those pants and jackets cost in stores, maybe due to inflation rates, right? So there's a lot of variability, but you can account for that based on making sure those data connections are live in here. What I'm doing by inputting this model manually is it's kind of hard-coded, right? You'd have to come back and re-update all these values on a daily basis. So I'm going to enter that model manually for now. And this is linear, right? The more pants and jackets I sell, the more money I'm going to get. So I'm going to leave that. There are some other problems like quadratic and mixed integer. I have yet to see really this in the wild yet, so I don't really have a good example of someone putting that to good use. This one is a really popular one if you're into scheduling, right? So something that's really binary, like should this person work today or not? That's a mixed integer problem. If you're looking for something more continuous, right, like the number of pants and jackets you should sell, that's a linear program. And do note, at any time, if you want to discover more of these, I recommend going to this Help, Sample Workflows, Predictive Sample Tools, Prescriptive Analytics. So you could see an example of workforce scheduling, right? And that's a mixed integer problem. So if you actually want to see that in action, you can go ahead and click on that and see how they've configured it. The next thing up is this toggle, maximize objective, okay? By default, people tend to forget that this is here, and the problem is they won't get the right answer that they expect. If this is left to the default, which is off, what it's going to do is minimize. It's going to say, what is the least number of pants and jackets that I can make today to make the least amount of sales, okay? That is an expected behavior, right? Sometimes people want to minimize. Something like, what is the least I can spend in terms of being the most optimal? What is the least I can spend on this inventory to make sure everything's in stock, for example? In this case, we're just trying to get as much as many because we're on the other side of the house, right? So we're going to leave that on. Next is this variable list, okay? And this really represents the number of pants and jackets. And you'll see that what I did is I did X and Y. I did that for the sake of just showing you how they interplay on a graph together. But if you're working in this environment, I actually just write them out, right? So let's just say jackets, comma, pants, okay? Now I will say, if I were to leave this view and come back, my variables aren't really entered yet, right? What I need to do once I do this is click this plus sign, okay? And that unlocks a new view, which basically means I've submitted my variables. Now I'm available to build an objective around them, some constraints, and different bounds, okay? So let's go ahead and say, let's just enter our objective. So we said $50 for every pair of pants. Okay, and if I don't know if you can see it on this view, but you'll see that pants highlighted. If it does not highlight, you did not have the right variable, or they might not be separated correctly. But if it's highlighted blue, it means it's the correct variable. So I'm going to say 50 times pants, and then 40 times jackets. I'm done. That's my objective. Okay? So let's go over to our constraints and build those out as we saw them. So there's one important thing that I want people to know is when you saw me go ahead in the previous view of our PowerPoint slide when I isolated Y, just so I could chart it, that is something just so you know in the background is happening. But in order for our constraints to work in the optimization tool, leave all of your variables on the left side, left-hand side, LHS is what we say, left-hand side of that equation, right? So I actually leave them as I proposed for my grid, where it was pants, this is for my first constraint, plus 1.5 jackets is less than or equal to 750, okay? And I forget, I think this is my polyester constraint or my cotton, but I don't quite remember, but you'll get the idea. Now, same thing with the variables. I need to hit this little plus sign to make sure it's kind of submitted as a constraint. Now, let me go back again and write the second constraint, whether it be polyester or cotton, and say 2 times pants plus jackets, it was just 1 jacket, is less than or equal to 1,000. And I'll submit that in. So objectives in, constraints are in. Now it's just the easy peasy bounds and types. So jackets, we said there has to be a bound between 200. They need to manufacture at least, oh, I'm sorry, this is jackets. I said this for pants. Pants, there needs to be at least 200, and that's it. It can go all the way up to infinity. I'm going to click Save. Okay. For jackets, though, it was anywhere from 0 to 400, and I'll save this here. Okay. Now, finally, this is there's some selection saying what type of bounds are these? Okay, are they continuous? Are they binary? Are they integer? So really, what kind of problems do we have? Binary would mean 0, 1. We're certainly going to have more than 0 or 1 jackets, so we're not going to do that. That's something if it's more like scheduling, right? Are they working or not? That's a binary problem. Continuous would be, they could be up to fractions, and I don't consider 2.2 jackets to be a real number of jackets. So I'm just going to say it has to be an integer. It has to be a whole rounded number for each of these. So the final thing that I actually neglected, but you might be wondering about, is this solver here. So this solver is essentially just in the background using R, what kind of a solver is being used to calculate this problem. As a general rule of thumb, we recommend that anytime you use a linear program, you go the GLPK route. If you do get into quadratic, we recommend Symfony. But if you were to toggle between the two, in this case, they would produce no different results. One would just run a hair faster than the other. So I'm going to go ahead and run this. And the one thing that I'll say is when you run this tool, you'll find this to be a very iterative process. And I was 90% sure for some reason something was going to fail here because that's usually the case. And I would tell people don't despair, right? Just go ahead and inspect, but there's a lot of things going on in one tool, so that it's not uncommon to get an error. Just go through and inspect and make sure that everything is well aligned. The other thing that I do as well is this is one of those tools that's almost always an open documentation tool. When I say that, I say I almost always open a sample workflow just to make sure that my configuration is right and I have something to compare it to that works. And if you do get something that works, save it off for later, just so you know how you can configure them at a later time. So here I have my output. I have just kind of what we call our simple data view, this S. And you can see what it's calculated is exactly what we've done inside of our presentation. I've calculated what the actual maximized sales is going to be, how many pants, 375, and jackets, 250, to be my result. Now, if I were to run this again as a minimized, you'll see that I'll probably get a very different answer. I'll probably get 0 of one or the other. Yep. So I can see, at the very least, if I were to meet the minimum requirements, I would sell $10,000. And this could actually be a really interesting thing to do as an upper bound and a lower bound, just to actually see how much money you're probably saving if you did the worst case scenario, right? So in this case, I've saved, or our actual objective value maximized was $28,000. So I've saved ourselves about $18,000 over the worst case scenario, almost $19,000, which is more than double of what we had here. So you can see the power of that. Now, if I wanted a more detailed view, I could jump into this D view where you can see everything's pipe delimited here. So you can see, for example, that pants, it recommends that I have 375 and they cost 50 a piece. And this I just represents that integer type that we set on our bound. Here's our jackets. And then over here you can see some constraint views of what was actually plugged into those. So that's the descriptor. Now, if you wanted to drill in and you had a bigger list, this might not be too exciting because I only had a few views here. Let me just open a new window. I only had a few variables. It's not that exciting to see this view, but I actually break down of where each of those variables are, what the values are, so on and so forth. So this is a good little interactive way of breaking down how each of your variables behaved inside of the tool. So that is the manual configuration in a nutshell. Okay, now let's jump back to our presentation and talk about the next thing. Let's talk about, we already talked about these simple data inputs, outputs, data, interactive report, manual inputting versus using matrices. Matrices meaning connecting data to your tool. So my recommendation is anytime you're using a manual input, the model is static and probably something that you will just save off and never really use frequently. Not really a scheduled thing because it's going to be the same answer week after week. It only works if a lot of things are fixed, right? My cotton polyester inventory is the same week after week. I'm only allotted a certain amount a day, and my pricing stays the same, or my manufacturing limits are fixed. And even if all of those were fixed, imagine how difficult this manual configuration process would have been if I had to do this for 1,000 variables, right? Imagine that type of constraints list that I would have to build. That would be difficult. And then finally, representing the problem mathematically, right? And that probably just stems into the number of variables that I have out there. The way of writing 1,000 equations would be probably challenging and time consuming. So let Alteryx do the heavy lifting. This is probably only better for those simple problems you need along the way. So use matrices. Anytime that your model needs to be dynamic, you have great variability in your data, and you just have this data pipeline connected to an Alteryx, where anytime you might find this work tedious, and you've already found it out, found this work tedious. Now, if you want to kind of graduate your way there, you might want to start with a manual input and make sure that it's solving the correct way for maybe just 2 pieces of your problem, and then start to introduce more and more, and then finally flip it over to work within matrices. That could be a way of approaching this problem. So you probably saw it in the last one. What are all these inputs for, and what do they really mean? So in manual mode, we said no inputs required, which is why there's all that gray space, or those gray anchors. Same with input from a file. So the really only time that you ever need those anchors is for the matrix input mode, okay? And there are really a few that are required, but most of the time you'll probably use these O, A, B, okay? O is required and A is certainly required, and B, I would say it would be very rare if you didn't use it, okay? And what these really represent is what your objective is, and A and B represent left-hand side constraints and right-hand side constraints, which you already know, but you may not have been introduced to that term yet, so we're going to get to that. And then finally, Q, which is for anybody using those quadratic programs. You'll need that anchor, but in this case, we don't, since we're solving a linear problem. So this is where I tell you that open documentation is going to be helpful, because your data needs to be structured pretty close, or if not exactly, to what I'm showing here, okay? So pay close attention and always work off a template. So what we're going to pipe into our objective is a few things that we're going to need, right? Our variable, which we declare as pants and jackets. We're going to need a coefficient. In this case, the coefficient was the amount of money each of these pants and jackets cost in order to obtain that sale. And that is usually shown when we wrote it out as an equation, an objective equation. You could see that they were simply quote coefficients on the front of my variables. And then I need to define my type and boundaries. Okay, so everything that we did here needs to be part of that objective data pipeline. So here I say type, and I'll probably open my help menu, but C is for continuous, I is for integer, B is for binary. In this equation, what I should have written is I, because I selected integer instead of my manual configuration. So type is equal to I, and typically this is just simply adding a formula tool, creating a new field called type, adding the letter I to all the variables, and we're good to go. Setting my lower bounds, so my pants are 200, my lower bound for jackets is 0, and then anytime there's an upper bound, you can just type in infinity. And also, I believe a null value is an inherent infinity. If there's no value, it assumes infinity. And so you can see I've assigned that. So all of that needs to be piped in right here into my objective. And the only thing that leaves after that is constraints. And constraints need to be broken into two pieces, the left-hand side and the right-hand side. Okay. So A and B, A is left, B is right. So over here on my constraints, if I were to toggle over here, I wrote two pieces of constraints in one place. So let me bring this up. Left-hand side is literally the left-hand side. The right-hand side is literally my right-hand side. And not only I'm including the actual operator as well as a part of that. Okay. I did mention that you will want to keep everything on one side of the equation. You'll see that this is a little bit different, right? You can actually see what I've given is the same view that I gave earlier in this presentation where I built that grid up saying, hey, pants take 1 square foot, they take 2 square feet of polyester, so on and so forth. So it can insinuate how much of each of these we're going to use. But what I did here is I just modeled my left-hand side, 1x plus 1.5y, right? Should be 750, 2x plus y, and polyester less than or equal to 1,000. Now, this is where there is a piece of confusing bit. And you can flip these around, but I'm just speaking to how most of the documentation will read, is how do we write these right-hand side constraints, okay? And why have I not associated this with 750 here or 1,000 here? Well, that's what's going to go into our B, and you need to make sure that they're aligned accordingly. So let's jump over to our B view here, and I'm keeping a view of my left-hand side constraint input, my A input up here, because it's important in formatting my B, okay? My B is literally going to be what's on my right-hand side, less than or equal to 750 or less than or equal to 1,000. However, pay attention here. The first row here is going to pertain to the first numeric column here, right? The second row here is going to be the second column. So you need to make sure that you're ordering your rows based on the ordering of columns here, okay? And that's going to be a really important piece to working with this tool. And you'll see there's actually a way to flip it, but once you learn a way, you might find yourself going in that same direction. So make sure that you name those fields directionality, dir, right, and right-hand side constraint, and then you're all configured to let it run. So let's go ahead and just show a quick view of that in action, and then we'll just wrap it up and try to answer a few questions here. So what I've got here, and if you opened our download file from the live training site, this is exactly the file you've got. The same data presented in two different places. Let it run out here. There we go. So I've got my objective built out here. I've already built my type, but if you needed to, you could just add a formula tool just to type that in. Now I have run it through autofield tool. One of the biggest problems that you're going to have working with this is data types. Hands down data types. You need to make sure that when you're working with these constraints, especially, that you're working with numeric values. Okay, so pay close attention to those. If you do have an error, more likely than not, it's a data type issue. So pay attention to those, and again, open any examples to see what data types those are consuming. So here I have a view of my pants and jackets. My type is continuous right now, lower bound 200, upper bound infinity, 0 to 400. Over here I've got my constraints built out into a table themselves. and then I have my right-hand side constraints. So less than or equal to 750, if I were to toggle up here, is going to pertain to my cotton field. Less than or equal to 1,000 is going to pertain to my polyester field. Now in the actual configuration of the tool itself, I have specify a model as matrices. I have linear program, GLPK, maximize objective, nothing any different than what we've done before. Now, here's a view of what you get to define. So constraints in rows or variables in rows, okay? Now, this is for the input anchor A, right? So are my variables in rows or are my constraints in rows? So if this was pivoted, for example, I would have to choose the correct view for this. In this case, I'm just going to leave it to the default because my my constraints are in rows. I believe. Actually, did it reset? We'll see. The final one is this O, display the input anchor O. And this is something that's actually new since I first constructed this training, and it's wildly helpful because before you had to be exactly precise in how you name these fields. But now you can actually map them in. So I could, if I had a field that wasn't named variable, I could just map them in to make sure this tool can effectively understand which tool is what. And I almost recommend always using that tool, and then you can run those. And that's all it is. It's just a lot easier to work with once you get it going. And if your data is kind of changing underneath you all the time, that's just going to be a lot easier to work with. So here I can see, and I may have bollocksed up my configuration here. Variables are in rows, I believe. But I could pan through this and I get pretty much the exact same results with the exact same data, assuming that I constructed my data in the exact same way here. There we go. So I made that mistake. I said my variables, my constraints were in the rows, but my variables were actually in the rows. So it is a little tough and confusing, but you can see why it's so important to kind of understand where you're going before you actually get this tool, because if you're trying to fly it out or figure it out on the fly and configure this tool, you're going to have a difficult time getting to the solution you need because you get so wrapped up in the configuration, you're not going to understand where you are or what you're trying to achieve. So always sit down, say, what am I trying to achieve? What are my variables? What are my objectives? What are my constraints? And what are my bounds? So, support. If you want to learn a little bit more about this, there are some good articles up there on the Alteryx community. One of our community authors, Sydney Furman, actually published one probably 2 months ago. That's a really excellent read if you want to understand this at a little bit of a deeper level beyond what I've talked about here today. Again, you always have the Alteryx Academy at your disposal. This recording will be posted up after this session. And finally, if there's something that seems wrong with your design or it's not calculating what you'd expect, go ahead and hit us at support@alteryx.com for any issues around the product itself. So that's all I've got here today. I appreciate everybody joining. I will stay on the line and just answer any questions if there are any more. If not, thank you for joining, and we'll see you next week.